Hi everyone. So today we will be starting on scalars and vectors. Mostly the intended participants are for class 11 uh, and on for the foundational JEE and so mostly I will be covering the basic concepts, okay, of how to go through each and every topic of scalars and vectors which is related to physics. Okay, so firstly I want to divide my section into few of the parts of it. So for physics, always we have to remember that mathematics is actually the language of physics. So always it becomes easier to describe, understand, and maybe apply the physical principles if one has a good knowledge of mathematics, right? So first we will be now I will be toggling, to our vectors and scalars concept, like what best we can do on concept wise. So just give me a minute. Hopefully all you can see my screen. Okay, so let me come here as we will see like what do we mean for the vectors and scalars. Okay, so mostly I will first tell about scalars, then we will understand the principles of it. So scalars means wherever we have uh, a physical quantity, a physical unit of measure that is linked, so we can call it as physical quantity. Okay, and but scalars do not have any direction. Okay, so for example, if I give as mass. Okay, so mass, mostly how we mention is that a particular material which is having a mass of 5 kg, right? But 5 kg doesn't we do not have to define any direction of his as such. 5 kg means 5 kg. Okay, so this kind of units which are completely defined by its physical quantities uh, and can be described in a numerical value alone can be mentioned as a scalar quantity. Fine. Whereas in vector, there will be two things of it. Correct. So one is same like this, our scalar part. So let me, for example, let me highlight. So there will be the physical quantity of it here itself. So number one is same like the scalar part of it. Okay, but on the other side, it also has a direction. So direction in the sense it should have a direction, like maybe this is towards east. Okay, so this is towards east. Sorry, my handwriting is, it may looks like a pre-primary, but actually just I'm trying to fine tune accordingly, because we can use in future like normal touch pens and all, so that would give a better representation anyhow, but for the concept I think that should be fine. So okay, so this is towards east. So now coming to the north of it, for example, a particular material matter or a object which has a velocity, right? So once, for example, this is towards north, so velocity is basically a vector. Why? Because we will specify, for example, a person running maybe 50 meters per minute. Okay, 50 meters per mtr. So I'm just writing in this way, 50 meter per minute. Okay, so if it is 50 meter per minute, that means that, and we have to specify towards east for this example, or towards north, because this has a direction of it. Okay, so maximum you will see lot of maybe different sources where you can learn, or this there are hundred and thousands of links, YouTube channels, and those things. But there might be a very basic concept that what is the difference. And I have seen that 90% of the student, what they write is as these two examples. Okay, these two means that vector has a physical quantity and a direction. Scalar only has a physical quantity. Okay, so that's not the case. There is also a third point apart from this two. Okay, so let me just, I think this concept wise is fine. So let me erase the first and second point of this too. Okay. Fine. So there is a third point which actually specifies there is a law called as the triangle rule of addition. This is the third point. So conceptually, you should mention this also. This is called as the triangle rule of addition. So what does this means? So this triangle rule of addition applies only for my vector quantity, and it doesn't apply for my scalar quantity. Okay, this triangle rule doesn't apply for scalar quantity and it applies for vector quantity. Fine. So we learn three things, three main differences. So for scalar, it will be having only the numerical value. Okay, and no direction is involved in scalars. So vectors will have number one, numerical value, number two is the direction, and number three is it should satisfy the triangle rule of addition. Okay, so these are the three things. So few of the common examples of vectors are, for example, force. Okay, so force is a example of, okay, or maybe velocity can be an example, whereas few examples of scalars can be mass. This is one of the example. We can consider mass, or maybe even we can consider weight. As of now, you can think, because we do not have to specify, okay, 5 kg towards east or maybe weight towards north, right? Whereas force or velocity, you have to specify on, apart from the value, you have to also specify towards which, whether it's towards east or west or north. So in this manner. Okay, so now we will deep dive into triangle rule of addition, and the way I like to go through is not directly that we will be mugging things, right? Because I have seen a lot of students or maybe a lot of foundational courses where they give like lot of rules and theorems. They just mug it up. But before that, we should know what are the internal concepts behind it. So right now, I think this is fine. So I will go through the triangle rule of addition. Okay, so let me just, okay, so now is the triangle rule of addition. So this I will go through just giving an example of it. For example, there is a particular, for example, there is a tube. Okay, tube in the sense, this is a tube, for example. Okay, and there is a small, just one sec. Yeah, there is a small ball here. There is a very small object. There is a ball over here. Okay, so let me just, okay, this is a ball. Okay, so right now for example, a person, he throws the ball from here, okay, in this direction. So this ball is having a direction towards this size, and a other person who gives a force towards this side. Okay, so if you see, there are two parts of it which this particular matter is getting, right? So one is towards this x-axis. Okay, let me change the color. Maybe it's very hot. Yeah. So this is my ball. So this is the x-axis and this is the y-axis. Fine. So here x-axis is the internal force that the ball is going, and this is which externally I am giving a force towards y-axis. In this case, what happens? There is a resultant force created. Let me not call it as force. Let me call it as vector. Okay, because this is a matter. Okay, this has its internal numerical value. Maybe this is the value is coming, like you can consider maybe, for example, 3 meter per second or maybe 4 meter per second, this ball. Okay, so let me tell it as, yeah, let me have it like x-axis is 3 meter per sec, and this y-axis, this force I'm considering 4 meter per sec. Okay, so here normally what would happen? There will be a resultant force towards this side. Okay, so this is the resultant vector of my x and y axis. This would be my resultant vector. And to understand that, what we will be doing, there are two things of it. So any of the vector quantity has two parts. One is my starting point, right? One is my starting point. This is called the head of the vector. And sorry, just let me rub it. So there are two parts of it. One is called as the head part, head, and the other is the tail. Any of the vector will have these two things. Okay, why I'm coming on the head and tail concept. Let me tell you, then accordingly you can just you can conclude for any of the vector cases on your own way. Okay, so here this is my head and tail. So head means towards where it is heading. So for this vector, this is the head part and this is the tail part. For this vector, this is anyway the resultant vector, but let me call it the base vector. For this vector, this is my tail and this is my head. Okay, so this is the main concept of head and tail. Okay, so what we are seeing is, this is my first velocity and this is the second velocity, and accordingly this is my resultant one. Okay, so this I will come into each and every, conceptually the mathematics behind it, but first let's go through very fundamentally, then we can deep dive each and everything. Okay, so what we learned is, for any vector there is a head and tail. Okay, if there are two components of it, x and y, and this is my matter over here which is applied, and accordingly I have a resultant vector. Fine, so I think this is clear. So right now, any of the vector, for example, this vector I specifies as, let me just rub completely and then I draw a fresh figure. I think this is fine. So now, so for example, now this is my two vectors. Maybe this is, I am stating as vector A, and this is my vector B. Okay, and this is my resultant vector. Let's denote as C. So what we can conclude here is C equal to A plus B. Okay, but whether this way of writing is right or wrong, it's wrong. Why? because this addition is plain simple scalar addition, but I am speaking about vector. So for any vector, how we write is there is a vector symbol for each and every case. And here we will have C is equal to A plus B. Okay, so this is the first concept. You can note it down. So one towards the X and Y axis, I will come to, this is just, we are speaking about two-dimensional figure. For the three-dimensional case, there will be also a Z axis also behind it. But Z axis I will come later. Maybe there can be another one as the Z axis. This is my X. This is my Y. And this may be my Z1. I will come to the Z thing, but before that, this is my core concept. So any of the vector, you have to write in this symbol. Okay, and accordingly, whatever the components you have to write, and what is the resultant vector, that will be the resultant vector coming over here. Okay, I think this is fine. Now we will come to each and every properties. Okay, so one is equality of vectors. So now we will speak about equality of vectors. Equality of vector means what? The same figure I can draw so that you can understand better. So equality means a vector can be stated as an equal vector if and only if the magnitude and the direction are same. Fine. So for example, let me draw a figure in this way. It will give a easy way. And I want to open all the windows. Once you are going through the fundamentals, right? So you should always be aligned, like how you have to think of. Okay, for example, let me do it in another way for a better understanding. Yeah, let me just draw, for example, this is a force applied. Okay, and the other force is applied in this way, same way as I was. So this is one vector, maybe A, and this is a vector B. Okay, so the resultant vector will come maybe C. So this is my resultant vector. So I can write C equal to A plus B. Fine. So now what does a equality of vectors means? So what we are going through is equality. Okay, this is called equality of vectors, and I will tell when this is mostly required. Okay, so equality of vectors is only and only when, for example, this is a vector. Okay, so for example, this vector, I mentioned this maybe as velocity. We can take the same example. So it's, for example, this is 3 meters per second. Okay, this is towards east. So now a vector will be, for example, the other vector is A sharp. Okay, so this vector, if also carries the same magnitude with the same direction, okay, with the same direction, that we have to mind. So if A sharp is, this is my A sharp. Okay, so this will be the same. This is called equality of vectors, and I will come to that when it is required, A sharp. Okay, so equality of vectors when it is required. For example, there is some kind of a problem. Okay, I will come to the problem, but before that, okay, before going to the problem, first let's this is my equality concept. So this concept we will utilize while we are doing the vector addition. So after this we will go to vector addition, and then you will learn why this equality is very important for any of the vector vector addition or maybe subtraction, wherever it is required. Okay, so anyway, you can just, as a nutshell, you can just think of equality means a vector which is having on the same direction and same magnitude can treat as the equal vectors. Okay, so this is what it is. Let me rub it. So right now we'll go to addition of vectors, and here again I'm stating the same point once again. So addition of vectors what's the difference? How I go through and I like is, you cannot avoid, if you want to achieve something good, right? You cannot avoid uh, a shortcuts. I mean, many of the people, they directly jump, for example, that they mention, for example, that I will give a formula directly. For example, the resultant vector is equal to there is a simple formula for any of the resultant vector, that is like root over a square. Lot of people, I mean, lot of students say no, plus 2ab cos theta. Okay, I think already many people know. But the way I like is, where from this is coming, you should know, right? Why? Because I know this is a very generic thing, and in future everything cannot be drilled down in that way. But while you are going towards fundamental, you should know how, where from it is coming. So from there, I am just going through the background, where from this formula is coming. Okay, so for that, the same concept. So let's draw a normal figure. Okay, so this is my AC vector. Okay, so this is my AC vector. Once vector, you can give the sign of it. And this is my another vector called as, maybe what you can consider, for example, this is a point AB. Okay, this is my another vector AB. So what we knew, that the resultant vector will be towards this point. Okay, correct, towards this. Fine. So where this, if this is my A, for example, let me rub it, give a, okay, so this is maybe my A vector. Okay, and the other part of is, maybe this is my B vector. Correct. So now the resultant vectors will be my this way. Correct, this will be my resultant vector, because this is a component and this is a component. I am coming to the angular part of it later. So let's first, on basis of whatever we have learned till now, I am just drilling down. Okay, so the last time, you remember, like I had mentioned equality of vectors. So for any of the parallel vectors, those are always equal, like for two parallel vectors having the same magnitude. So considering that principle, let's do one thing. Let's draw a parallel to this. For example, the parallel, let's draw in this way. This is my parallel mostly. Okay, and I am just making it as a normal uh, I am just completing the parallelogram. This is actually a parallelogram. Okay, so my main intent, what is my main intent is to get the resultant vector. What is the value of the resultant vector? Fine. So now coming to the conclusion, I mean, here, for example, for these two vectors A and B, it's having a value of theta. Fine. So if this is having a value of theta, I think all of you have basic knowledge on mathematics. So if this is theta and this is my baseline, this is also parallel to it. So this also will come as theta. Fine. So this is one part. Let's complete the figure. Let's make it a rectangular over here. So I have mentioned A, this is my B, okay, this is my C, and this is my D, and this is, for example, I'm mentioning as E. I am coming to this, why I draw this line. This will be for my calculation. Okay, so till now what I know is from here, AD, this is a vector. What will be equal to my AE, correct? AE plus DE. So mostly how it should be, this one, let me make it, don't call it as vector right now, because I'm coming to that vector point. So this is simple mathematics I am telling. So here, sorry, a day square is equal to will be a e square plus b e square normal. Just see. So if I highlight here, so this is like simple mathematics, nothing to do with physics. Okay, so a d square, okay, is equal to ae square plus ac square, because this AC is basically the same value like this. Okay, so my AD square is equal to AE square plus DE square. Fine. So let me just rub this part and I will come. So here AD square is equal to AE square plus BE square. Fine. So here, let me drill down. So AE is basically AB, this one, the small one, then the BE, because this is my AE. So AE, I'm making AB plus BE. So AB plus BE square, okay, plus BE square. Internal calculation you can do, but I'm just drilling it. So AB, okay, now coming to AB. Fine. So AB is basically how I can write. AB is my A vector, correct? So AB is my A vector. What is BE? BE. So if you see, this is my theta. This was my also my theta. So right now BE can be, we can write is as, because if this is the B, this is also my B, correct? Because these are parallel to each other. Those are the same thing. So we can write, what is BE then? It will be B cos theta, right? Because BE by B is equal to cos theta. So BE is equal to B cos theta. Fine. Plus now the BE component, BE square. Okay. So sorry, I have written wrong. So this will be DE square. So very sorry. This will not be BE. This will be DE. D, because basically AE square, okay, plus DE square. AE square plus DE square. This is what it is coming. Okay. Let me remove the highlighter. Okay. So AB plus now DE square. This DE square is basically the same way. If this is my B, so sine theta is equal to my this part of it, the perpendicular part of it, correct, by this value is equal to sine theta. So basically this will be coming as BE will be coming as B, sorry, this will be coming as B sine theta squared. Sine theta squared. Okay. So here it's basically, if you drill down, it will be from here, it is coming A square plus 2AB cos theta plus B square. A square plus 2AB cos theta plus B square. Okay. So this is my AD square. So then hence coming to a conclusion, what would be my AD? AD is it equal to root on of all A square plus 2AB cos theta plus B square. Okay. So from here it is coming. So maximum people, they will be going towards this concept, but you should know where it is coming, because there can be some kind of a question also coming where the basic concepts are also required. Okay. So this is my AD. So 2AB cos theta. So it means two vectors making an angular between these two vectors will determine the overall resultant vector of its AD. So we got the AD concept. I think it's clear, right? So right now the other part is, there mostly there is a other problem that comes. For example, this is making a angle of alpha. Okay, so mostly sometime there is a concept like what is the angle been created with the vector A. Okay, so in that case, what is the angle actually overall? So in that case, it will be basically tan alpha, because we know the tangent is basically the angle that has been created of 2. So tan alpha is equal to dE by AE. Okay, so mostly dE by AE will be the tan alpha, which will come to as B sine theta by A plus B cos theta. Okay, sorry, maybe the page looks bit, but here from the concept comes. So there are two things of it you have to take over from here. One is the tan alpha. If this is my alpha component, so you can remember B sine theta plus A by P cos theta, but this is the way where from it is coming. And the resultant vector is, this is my resultant vector AD. Okay, so mostly this is the way overall how it is coming. Fine. So now maybe problems we will come to the next class. Okay, but I can just go through maybe one very simple problem, because after your concepts are clear, if you do a very basic problem, it always gives a good test that you understood the thing and you are able to do it actually. Okay, so let me give a basic problem. For example, there are two vectors having equal magnitude A. For example, there are two vectors of equal magnitude, like this is also A and this is also A. Okay, this is maybe my origin line OX I am telling, and this is OY. Okay, this is, so on basis of whatever we have learned, what is the resultant vector that will be created? And for example, this has a angle of theta. Okay, overall this has a angle of theta, the same way that we have learned between the two vectors, and this is my resultant vector. So from here, if the values are same, both are A, what will be? So I know my, if this is my resultant vector B, so B is equal to our same formula. What was our formula? A square, right? So let me write A square. What was earlier? It was A square plus B square plus 2AB cos theta, right? But here both are A, so B also carries the value of A. So A square plus 2A square cos theta, correct? So what it will come? Root over 2A square 1 plus cos theta. Okay, so this will be, you can calculate, this will come as a value of 2A cos theta by 2. This is purely mathematics. I'm not going to the more drill down, but this will be, so you learned right now that this was a common problem and you achieved like how to do it. Okay, so this is one thing. So we learned how the vector addition, how the resultant vector we can calculate for any of the cases. Okay, so right now we will go through multiplication of vector, because same like scalar quantity, this is also a mathematical very powerful tool, the scalar vector. So the same thing you can achieve for all the numerical addition, I mean addition, multiplication. So right now comes to the multiplication. So multiplication is very theoretically you can understand. For example, in scalar, how we do? In scalar, we do, for example, a particular concept. Maybe if A equal to B, how we write? 2A is equal to 2B. This is a scalar thing I'm telling. Same way you can write here also. For example, this is my vector quantity. Okay, so 2A is equal to 2B. Okay, so in vector there is a other concept called as the unit vector. Unit vector means in physics, as you know, any of the physical component has a defined description, right? So for example, this is my b vector, huh? So how I can write is b vector to be as, there are two parts we learned, one is the magnitude and one is the direction. So we can write this b vector as in this way, b, okay, how we can write, b is equal to b into, this is a dot and scalar product, I will come later. So b into the I vector. I is the unit vector towards that. This is the magnitude part and this is the direction part. So overall, this is my vector that we achieve. So this is how the multiplication we do. Multiplication of vector we can do in this way. Okay, now coming to the subtraction. Subtraction is very tricky and very easy, and there are a lot of questions that comes in subtraction. Subtraction is very easy plus but bit trickier in the angle wise. For example, uh, this is my vector A. Okay, now if someone says that I want to go to the negative direction of it. Okay. Okay. So this will be my negative vector. Okay. So how we do the negative vector of it? So if this is my A, this is also my A vector, but this is the negative vector of towards this vector. Okay. So just coming to a real time example. For example, how can you do the subtraction of two vectors? Okay, so let me go here. How can you do the subtraction of two vectors? Same like that. For example, conceptually, for example, this is my vector A, this is my vector B. Now always remember to give the vector sign. Now, always what we learned earlier, this will be my A plus B. Okay. Now, right now, what I have to do? A minus B. Correct. So here, just go through the diagram and try to uh, try to uh, I mean exactly form the solution. Okay, so here you see A minus B. What I can write is A plus of minus B. Correct, that gives the same thing. So how I can then form pictorially? Same way, if this is my B, then this is my minus B. Simple. So if this is my minus B, then this is my resultant vector. And what would be? A plus of minus B. Correct. So this comes A minus B. Cool. Okay. So same way, for example, this is my theta. Okay. Now my theta is 60 degree. Okay. Now what I came to that earlier logic, that would be this if this is my resultant vector, this will be uh, a square, sorry, this will be root upon the same thing I'm just writing. I do not want to again go to the same thing. 2ab cos theta. Correct. This is my original theta. What would be this now? Because right now we are doing minus. What would be this now? If this overall is my, if because we know this is 180 degree. Correct. So if this is my theta, what will be this value? What will be this value? This value will be 180 degree minus theta. Okay. So while you are actually doing the resultant for for the subtraction case, you have to always make this theta a square plus b square plus 2ab cos 180 degree minus theta. This will be your concept. Okay, over once you are doing this. So you there in that case it will be square plus 2ab cos 180 degree minus theta plus b square plus b square. Okay, so we learned the subtraction also. Fine. So this was the case of subtraction. So right now, mostly I think we have learned basically what is vector, what is scalar, how the vector we have to treat, what is unit vector, what is equality of vectors, how we can do the addition and get the resultant vector. Okay, how we can do the multiplication of vector, subtraction of vector. So there is right now another concept. Maybe there are two other concepts. Then I will just close for the session today. So the final thing is resolution of vectors. So this is very important thing. So now once we tell resolution, what does it mean? Resolution means basically the projection of vectors. Okay, so vector projection. Now you are slowly deep diving into core concepts, very core concepts, and you will get lot of, I mean, foundational joint mains exam. There you will get few of the questions on the projection or maybe resolution of vectors. Okay, so the same way, but I will just treat in a very simpler manner what does resolution or maybe projection, what does projection means. Okay, so whatever you have learned till now, the same thing, but I will make it in a separate bucket of it. Okay, so for example, this is my same concept, this is my origin, and this is, for example, this anyway, people know this is x-axis, so I'm not writing it. So this is maybe my I vector, and this is my y-axis, and this is my j vector, this side. Okay, and same way, I'm just not repeating again. So, and this makes an angle alpha, and this makes an angle beta of it. Okay, so here, what does projection means? Projection is basically there are two parts for this resultant vector OA. So OA can be written as OB plus, if this is my C, so we can write OC. Okay, so projection is nothing but this resultant vector has two projection vectors. One is towards X, this is towards X, and this is towards Y. So this is the projection vector of towards X. So this is basically the OX component. So which we can write it as, for example, if this is my resultant vector as A. Okay, so we can write it as OB is equal to A cos alpha. Okay, because if this is my alpha, this is my A, so what would be the OB? Same concept. This is mathematics, nothing different. So this will be A cos alpha. Fine. And on physics terminology, you have to write a I because this is a unit vector. So this is towards x-axis projection. The same vector projection, this is the x-axis projection. And the same way we can write the OC. OC, this is my y-axis projection. So OC will be same way. It will be A cos. Now what? Tell me. This is my beta. So this will be beta, and this is towards y. This is a unit vector. Anyway, this is also a symbol we can write. So we can write J. Okay. So these are the projection concepts. So don't get afraid. I mean, projection means basically purely the components aligned to its unit vector means the projection. Okay, fine. So now let me just come to let me now come to a formula of it. Now this was again, I mentioned, I always like to drill down things, not just mug up. सिर्फ रट्टा मार के कुछ नहीं होगा, ठीक है? इसीलिए आई एम जस्ट ट्राइंग टू just drill down things how it comes. So you got for the 2 plane, right? Now if it is the 3 plane, now I am writing the basic formula. So in that case, if it is for example 3 plane, this is my resultant vector. R means the resultant vector is equal to A cos alpha I. This already we learned in the last example. Okay, plus tell me what will be B cos beta j. These two things I did. But if it is for y, x and z axis, what will be? Because axis can change, right? There are a lot of dimensions. I mean x, y, z. So in that case, this will be C cos beta. You can consider I, j, k, right? You can consider it as k unit vector. So this is basically my resolution of vector. How you are resolving your vectors into this. This is for a 3-dimensional 3D plane. You can consider in this way. But you have to conceptually be very clear why we are writing in this formula, right? So concept should be very, very, very crystal clear. No question on that. Fine. So this was mostly, there are another very small 2 things I will, and then I will close it. One is the vector dot product and the cross product. Okay. There are 2 things. This is also very useful. So there are a couple of times I have seen, like for the MCQ related questions, or maybe few of the conceptual problems, you require the dot and the dot product or the scalar product. Basically there are 2 things. One is called the dot product, okay, or the scalar product. What does this mean? Any idea? So always dot product or scalar product of 2 vectors, okay. So what these mean, dot product or scalar product? If there are 2 vectors, same way, if there are 2 vectors A and B, and this forms a theta, so the resultant vector, whatever it forms, okay, the dot product of these 2 vectors will be A dot B. Always remember to give the sign. This is important. Otherwise, examiner will give a big cross. Okay, so A plus B, A dot B is equal to AB cos theta. Okay, so always remember this is my dot product or scalar product of 2 vectors. Okay, this is my scalar product of 2 vectors. Fine. And the dot product is always, there are 2 properties we will learn. So there are 2 properties. One is called as the commutative property, and the other is called as the distributive property. Fine. One is called the commutative property and the second one is called the distributive. So what does this mean? So commutative property basically means that for the dot product, that A dot B we can write as B dot A. This is called internal commutative property. Okay. Few of the basic theories also you have to understand. Otherwise, in exam, you may think, what are these? Okay. So this is a commutative property. Okay. And the other one is called distributive property. So what is that? Distributive property is basically, for example, A dot, for example, there are B vector plus C vector is equal to, we can write A dot B, A dot B plus A dot C, normal multiplication how we do. So this is basically called the distributive property of the dot products of two vector. Clear? So now we will go to the, what is the other property? The other property, the last one, is the cross product. Cross product or vector product of two vectors. This is, the earlier was called dot product, and this is the cross product. So dot product, how we have written? Dot product we write as A dot B, right, in this way. And cross product, how we write? A cross B. So this is the cross product. So what is basically the cross product? Cross product is itself a vector, because dot product is not a vector, that is a scalar quantity, and this is itself a vector. If A cross B is denoted by Z, this is also a vector. So this is my cross product. So how we will write? We will write AB sine theta. Same, I am not just writing the same way if theta is formed in this way. This is my theta, and these are the two vector components. Okay, so A and B. So this will be my AB sine theta. So remember this concept. This is my cross product. And another thing, what will be the theta? Okay, so I was just making sure if all understand, this is not my theta. This is my theta sharp. So what is my theta sharp? So will come as AB sine. So what will be my theta sharp? Let me tell you in an example. My theta sharp will basically the angle formed, okay, whatever, which will be like, which is the smaller angle between the two, that is my theta. For example, 180 degree minus theta. Okay, for example, this is 30 degree, right? So you have to calculate two things. Here, if this is the theta, if theta is my, for example, 30 degree, so my theta sharp, the theta sharp will be, if this is my theta sharp will be 180 degree minus 30 degree. So it comes 150 degree. So always we will take the smaller amount. So here we will take the 30 degree. So this will be basically AB sine 30 degree, whatever is the value. Okay, the theta value, and we will be calculating 180 degree minus that value. Now, if this theta is my 120 degree, then what will happen? If this is my theta, then my theta sharp will be 180 degree minus 120. So it comes 60. So now we will take this 60. Earlier we were taking this theta. Now we are taking theta sharp, because always we have to remember that we are going to take the smaller amount formed between the two vectors. Okay, so I think lot of content, right? Lot of content. I do not want to overburden all of you. So mostly these are the basic concepts we have to go through and know very crisp, so that going forward it would be easy to solve the problems. Because vector is something in class 11, for any kind of physical movement you will have, for example, Newton's law of motion, or maybe friction, or maybe like mass, linear momentum, whatever you consider. So these vectors are always an essential part of it. Okay, so by that I want to maybe conclude on behalf of TutorOps. So that's it. Have a nice day. And maybe and the same way I'm going to go through in my next classes, for example, on the differential calculus. But again mentioning differential calculus is also something which, whatever just is required for our physics classes to understand and solve the problem, I will just highlight those parts. And it's not a class 11 mathematics, just to make sure of that. Okay, so by saying that, I want to conclude it. Okay,